This is the solution to quiz 12. Okay, so as a reminder, even means the function would satisfy f of negative x is f of x. That's the algebraic requirement. The geometric requirement is that it has a horizontal symmetry across the x-axis. Odd would mean that the function satisfies the equation f of x, f of negative x is negative f of x. And this means that a horizontal reflection is the same as a vertical reflection. Okay, so the question is does this f satisfy that equation, or neither one? So let's check. F of negative x is negative x multiplied by absolute value of 4 times negative x, which is negative x, and then that would be, you could write it as negative 4x, but that negative inside of the absolute value is cancelled, so that'd be negative x, absolute value of 4x, but that you could write as, say, negative x absolute 4x, which is negative f of x. And therefore, the conclusion is that f is odd. Okay, let's try the same thing with g. See what g does with a negative x. That would be 7, and then negative x to 4 minus 3 times negative x to 2. Well, because that's negative x to 4, an even exponent, that negative is cancelled, so that'd be x to 4. And then now again another even exponent, so that negative is cancelled. So this is the same thing as g of x, and therefore g is even. So for part C, to be even means that you could take this and reflect it over the other side and get the same thing. So the question is what would this see if it was looking in the mirror that way? Well, it would see this. So it would see that point. This is the point 5, 4. So 5, 4. And then this is the point, well, what is that? That's 2, 4, 6, 8. So going here, 2, 4, 6, 8. So what you want to see for this one is you want to see a horizontal symmetry. Now, for this one, you want a horizontal symmetry to be the same as a vertical symmetry. So the way that this one can be obtained is by first flipping it this way, just like the even case, but then taking the result and flipping it vertically also. So I'll do exactly that by looking at this one. So this point would go here. Then this would be 5 to the left and then 4 down. So this would be 2, 4, 6. 2, 4, 6. Okay. So that's the answer to question 1. For question 2, so we'll say y is 5 minus 8x. So now we'll swap the variables. X is 5 minus 8y. And then, so this algebraically was swap x for y, but do understand that the geometry is this was reflect across y is x. Okay, so now we're going to solve for y. Okay, so that would be, I could move the 8y over here, so 8y plus x is 5, so then 8y is 5 minus x, so then y is 5 minus x all over 8. Therefore, the inverse function is f inverse of x is 5 minus x over 8. So now, to verify, that would be, so first, f inverse circ f, evaluate at x. So that is f inverse of f of x. So that's 5 minus f of x over 8, which is 5 minus 5 minus 8x over 8. Well, distributing the subtraction, that would be 5 minus 5 plus 8x, and then all over 8. The 5's cancel. The 8's cancel. Okay, that's good. So that means that f inverse circ f, evaluated at x, just gives you x. And in the other order, f circ f inverse, evaluate at x. Well, that is f evaluated at f inverse of x, and that is 5 minus 8 f inverse of x. So that's 5 minus 8, and then 5 minus x over 8. So now the 8's cancel. Then I can distribute the subtraction. The 5's cancel. And we just get x. So as a result of these two, therefore, we have verified. Okay, so then question 3. Okay, so So for A, so -7, -6, -3, and 2. So let's plug in those values and get f of x. So if you plug in -7, that's -7 plus 7 is 0, square root of that is 0, plus 1, so this is 1. If you plug in -6, -6 plus 7 is 1, square root of that is 1, plus 1 is 2. Plugging in -3, -3 plus 7 is 4, square root of 4 is 2, plus 1 is 3. And then plugging into 2 plus 7 is 9, square root of that is 3, plus 1 is 4. Okay, so then let's plot those. So at -7 we have 1. So 2, 4, 6, 7, we have 1. Okay, at -6 we have 2. So that's 2, 4, 6, 2. At -3 we have 3, so 3, 3. At +2 we have 4, so +2 we have 4. Okay. So then if we were to plot a bunch of points, connect the dots, that's what f would look like. So now we can plot f inverse. Okay, so the inverse function is obtained by reflecting across y is x. Now, we could point for point reflect them, and that's fine. You just take this drawing, the red, and you twist it over the green, and you'll obtain the inverse function. But another way to think about it is we could take that table right there and say that we have x's and f inverse of x, and what we do is we swap the rows and columns. So that's to say 1, 2, 3, 4, and the values are now going to be -7, -6, -3, and 2. So observe that these switch. So this is the switching of the rows is the reflection, or like on the previous question on number 2, that's swapping x and y. So now we can plot these. So if you plug in 1, you should get -7. So 2, 4, 6, 7. If you plug in 2, you should get -6. 2, 4, 6. If you plug in 3, you should get -3. If you plug in 4, you should get 2, +2, right here. And then that point also has to be the same. So connecting these dots. have it. So this one is y is f inverse of x, and this one is y is f of x. Okay, so we did the plotting. Okay, so then for part C, we'll take y is equal to square root x plus 7, and then plus 1. And now we'll swap x and y, so this becomes x is square root y plus 7 plus 1. So this right here, this swap x for y is exactly the same as this swapping x's and swapping rows, and that's exactly the same as the reflection. So all of those things are 3 different ways to see what's happening in this exercise. So I'll move the 1 over. X minus 1 is square root y plus 7, square both sides. X minus 1 squared is y plus 7. So then x minus 1 squared minus 7 is y, and as a result, the inverse function is x minus 1 squared minus 7, and it has the domain which you can just read from this plot. Domain 1 to infinity. And that's the answer.